Okay, let's take a look at the chain rule. Now, so far you've looked at the product rule, the quotient rule, the power rule, but all of those rules and the rules for the trig functions, but those rules dealt with situations like this where you have, for example, sine x, y equals sine x, and we know that, dy dx is equal to cosine x. But what happens if you don't just have sine x? What happens if you have something like this? What happens if you have y equals sine, well, let's say 5x? Well, this derivative here is going to be different from the derivative of this. In fact, this derivative involves us using the chain rule. So we're still going to have cosine of 5x. But in addition, we have to chain onto that. We have to multiply by the derivative of the inside here, which is 5. So really, this derivative is going to be 5 cosine 5x. So notice, it's a little bit different. The derivative of sine x is cosine x. The derivative of sine 5x is 5 cosine 5x. So we're going to explore this chain rule a little bit. And I'm not going to do a thorough proof here of it. What I'm going to do is just kind of show you, kind of motivate why the chain rule works and how to use it. Let's suppose that we've got a function f of x squared like this. And I want to differentiate this. Well, here's what I'm going to do. I'm just going to write this as f of x times f of x. That's what I'm going to do. Because this is a product, and I know how to find the derivative of a product. The derivative of a product I can find by using the product rule. So I've got the derivative of the first times the second plus the derivative of the second times the first. Okay. Now look, there's two of these. See? Two of them. 2f prime of x. 2f prime of x times f of x. So I could just write this as 2 f prime of x f of x. Okay, there's a couple of those. Now let's go a little further here. Let's consider what happens if we've got f of x cubed. Well, I could write that as f of x squared times f of x. Yeah, that's f of x cubed. And then I could use the product rule. So here we go. Here's the product rule. The product rule is going to go like this. I got dy dx. Now I'm going to take the derivative of the first, which is f of x squared. I've already got the derivative of that. I found that previously. So that's going to be 2 f of x f prime of x. Okay? Just this right here. Times f of x. Plus the derivative of f of x. Well, that's f prime of x. So I've got f of x squared f prime of x. Now, let's see what this is. Notice how this looks. We've got 2 f of x times f of x. That's 2 f of x squared times f prime of x. Plus, here I've got f prime of x and f of x squared. So I've got this, f of x squared, f prime of x. And if you just dig this, I've got, these are the same, except I've got 2 here and 1 here. So the derivative is just going to be 3 f of x squared f prime of x. Now we could go on and on with this, but what we would find if we did this again, we would find that if I want the derivative of, let's say, f of x to the fifth, what we would find is this is going to be 5 f of x to the fourth f prime of x. And you kind of see a pattern forming here, where what we've got going is I'm taking the derivative of this outside, this thing raised to the fifth, and then I'm multiplying by the derivative of the inside. See? So let's look at this. Let's suppose that I've got y equals 7x plus 1 raised to the third power. So this is sort of like f of x to the third. And why don't I do this? Since I just did a fifth up here, let me make this to the fifth up here. Let me just make this a 5. Okay? So look what I'm going to do. I'm going to take the derivative of the outside. So here we go, dy dx. I take the derivative of the outside. So I've got 5 f of x to the fourth. See? Look at this. Look how it matches. 5 f of x to the fourth. 5 f of x to the fourth. See, it's kind of like that. It's kind of like if this 7x plus 1 is f of x, and then this is the power here, and then times the derivative of the inside. Well, the derivative of the inside, 7x plus 1, is just 7. In other words, the derivative of the f of x in here. So my derivative, finally, is going to be 35 7x plus 1 to the fourth. So this is a demonstration of the chain rule. Yeah, demonstration of the chain rule. So it's sort of like, now sometimes you'll see this, so let's look here. Sometimes you'll see this way. You'll see that if you have a composite function, like that, and you want the derivative, okay? So you want to find the derivative, dy dx. This is going to be, you're going to take the derivative of the outside times the derivative of the inside, like that. Where in this example, this 7x plus 1 would be like g of x, and then the f of x would be like x to the fifth. You've got a composite function. So this right here is the chain rule. Now sometimes you'll see this chain rule expressed using Leibniz notation, where instead of g of x, they'll have a u in there, right? So what they'll do is they'll express the derivative this way. They'll say dy dx is equal to the derivative of y with respect to the inside right here times the derivative of the inside with respect to x. Sometimes you'll see it this way, where it's like you have y equals f of u, like this, and they'll write the chain rule this way. Anyway, you'll see it written this way sometimes. I prefer to write it this way. Notice, the cool thing about Leibniz notation is it kind of behaves like a fraction, right? So dy dx, dy over du, du dx, it's like the du's cancel. So it makes it where you can easily remember what's going on with it. But let's look at an example here. Let's suppose that we've got this function here. Let's suppose we've got 3x squared plus 1 raised to the fourth power. So we've done a similar example. So we need to apply the chain rule here, and we've got an order that we want to go through. We're going to differentiate the outside function first, and then the inside function. We're going to then multiply by the derivative of the inside. So sometimes, what I like to tell students, in keeping track of the order to go in, just think about if you were evaluating this function, what would you do? You know, if you had a number to plug in here for x, first thing you would do is compute 3x squared plus 1. That's the very first thing you would do. Then you would raise that result to the fourth power. So you go backwards when you're differentiating. So I'm going to take care of the fourth power. So I've got 4 times 3x squared plus 1 to the third. Okay, I've got that taken care of. Then you multiply by the derivative of the inside, which is going to be 6x. And there you have it. So you know, you could write that, simplify it a little bit, and you got 24x times 3x squared plus 1 to the third. There it is. Okay, that's the way you do it. Now let's look at some others. Okay, let's suppose that we've got this one. Let's suppose we've got y equals sine 2x. Now, so I want to differentiate that. So here's what I do. I say, okay, what would I do first if I were just trying to evaluate that? Well, first I would plug in and find out what 2x is. If I were given a number, what would I do first? Well, I would put in and compute 2x. Then I would take the sign of the result. So we're going to go backwards. We take the derivative of the sign. And remember, I keep the 2x in there. That never changes. It's sine of 2x. Any trig function that I have here, it's going to have 2x inside. Now I take the derivative of the outside, or the inside, 2x. See? So there I have it. I have 2x times cosine 2x. Yeah, like that. There you have it. Now you could have more than just two functions. You could have more than one, you know, just an outside and an inside. So let's look at an example here. Let's suppose I've got y equals, let's say tangent. Let's suppose I've got tangent to the fourth power of 5x. And I want to differentiate it. Well, okay, I think if I had a number, I'm going to plug in and compute the value for a given number, a given value for x. First thing I would do is find out what 5x is. Then I would take the tangent of that, and then I would raise the result to the fourth power. So you can see the steps you're going through. So there's the outside, and you're working your way into the inside of the function. So here we go. Now notice when we do this differentiation, it's just a chain of factors, and it's not, they're not terms, they're not added together, they're multiplied. So here I go. I'm going to say, okay, I'm going to take care of this fourth power first. So this is going to be 4 tangent cubed 5x. Okay, I check that off. Then the next thing is the tangent. So I differentiate tangent. Now notice I'm not doing plus, I'm just multiplying it. Secant squared, and it's still 5x. That doesn't change. Okay? The trig function is it's a trig function of 5x, not just x. And then finally I've got the inside most, which is just 5. And there it is. Now you can go ahead and multiply things together, like this would be 20 tangent cubed 5x secant squared 5x. So, you know, doing that little bit of multiplication, that's not hard. We can do that. But you can see here we didn't just have an outside and inside function. We had, you know, 3 layers that we dealt with. But that's how the chain rule is applied. Now let's look at another one here. Let's suppose that we've got, let's put product rule and chain rule together. So let's suppose we've got 2x plus 1 to the third times 4x plus 5 to the second, something like that. Now notice this is a product. So the product rule is still involved. Okay? It's not like the chain rule. It's not like you have the chain rule and that's the only rule you use. Yeah, all the rules are still involved. The chain rule comes into play as you're applying the other rules. Like if you're applying the product rule and it comes time to differentiate the first, you've got to use the chain rule sometimes. So let's see what happens here. We've got dy dx. Okay, so I'm going to take the derivative of the first. Well, that requires the chain rule. Okay, times 2. See? That's the derivative of the first right there. That one. Times the second. Okay, that's the derivative of the first times the second. Plus, now I'm going to take the derivative of the second. Chain rule. See, there's the derivative of the outside times the derivative of the inside times the first function. See? So I've got the product rule going here, but within the product rule, when it comes time to differentiate these factors, I have to use the chain rule. Now I need to simplify this a little bit, and one way I can simplify is just factor out common factors. Notice I've got a 2x plus 1 squared, a 2x plus 1 to the third. I'll just factor out a 2x plus 1 squared, the smaller of the two. I've got a 4x plus 5 squared, a 4x plus 5 to the first, so I'll factor out a 4x plus 5. Now I can also factor out a 2. See? So I'll just put a 2 there. Now let's see what I've got left here. I've got this 3. I factored out the 2x plus 1 entirely. I factored out that 2, but I've still got a 4x plus 5. See there? Okay, I think that's everything, right? Let me just double check. If I multiply this back through, I get a 2x plus 1 squared, 4x plus 5. Yeah, got it. Now let's look over here. I factored out this 2, but I still got this 4. I factored out the 4x plus 5, but I still got a 2x plus 1. Yeah, there we go. Okay, now I might want to just clear my parentheses and add like terms in here. So let's see what we're left with. We have 2x plus 1 squared, 4x plus 5, and then let's see what's in here. We've got 12x plus 15. See, 12x plus 15 plus 8x plus 4. Okay, now let's see what's out. I think we're about done. Just about. There's not too much more to do. There we go. Now let's see what's in here. We've got 12 and 8, that's 20x plus 19. There. There's your derivative right there, using the chain rule. Okay, so that's an example of using the chain rule. Now I want to look at another one. Let's suppose that we've got y equals, let's say 2x plus 1 over 3x plus 2. And let's suppose we're raising this to the third power. And I want to differentiate this. Well, here we go. The outsidemost function is the cube function. See? So I've got 3 2x plus 1 over 3x plus 2 to the second power. See? That's the derivative. I've just used the power rule. Brought the 3 around, reduced it by 1 up here. This is the first step. Now, time to differentiate the inside. Well, that's going to require the quotient rule. So here it goes. The derivative of the top times the bottom minus the derivative of the bottom times the top. All over the bottom squared. There. That's the derivative. Okay, so there's another example. Now, of course, I wouldn't want to leave it like this. I think we can clean it up a bit. So let's just see. We've got 3 times 2x plus 1 over 3x plus 2 squared. Now let's see what's in here. This is going to be 6 plus 4, 6x plus 4. Yeah, 6x plus 4 minus 6x. Now be careful, this minus goes over here, minus 3. And then we've got 3x plus 2 squared down here. Now let's see here, the 6x's cancel, and we've got 4 minus 3. Ah, good, that's just 1. So let's see what we've got here. We've got 2x plus 1 over 3x plus 2. And then we've got 1 over 3x plus 2 squared. There's my derivative. Now I can actually clean it up a little bit more, because I could recognize this as 3 times 2x plus 1 squared, and then 3x plus 2 squared times 3x plus 2 squared. That's 3x plus 2 to the 4th. There. And there we have it. We've successfully differentiated this thing. And this was an example where we used the quotient rule, and in the process of using the quotient rule, well, we had to use the chain rule, and in the process of using that chain rule, differentiating this, the quotient rule popped up. So all these rules work together. Now, let's look at one more involving a trig function. Let's suppose we've got y equals sine to the 4th of 3x plus 1 to the 2nd. Okay? Now, there's quite a bit going on here, but let's think about if you were evaluating this function and you had a number to put in for x, what would you calculate first? Well, the 3x plus 1. Then you would raise that to the 2nd power. See? Then you would take the sine of it, and then you would raise that to the 4th power. See? So you think you're going to go backwards from what you would do if you were evaluating this function. So let's see here what we have. We have dy dx. Okay, I'm going to take care of this 4th power. So this is going to be 4 sine cubed 3x plus 1 squared. All I did was take care of that outsidemost function, then times the derivative of sine. Well, the derivative of sine is cosine. See there? So I've got that one. And then I'm working on this one now. So I go 2 times 3x plus 1. Okay, got that. And now take the derivative of 3x plus 1. That's just 3. And there you have it. And of course you could add the 3, the 2, and the 4. You get 6 times 4, 24. So I guess I can go ahead and do that. I get 24, right? 4 times 2 is 8 times 3. And then I've got sine cubed 3x plus 1 squared, cosine 3x plus 1 squared times 3x plus 1. And really, in practice, I'd probably put that 3x plus 1 out front. But anyway, I'll just leave it at that. I'll leave it there.